One of the things we know about multiplying and dividing radical expressions is that the expression radical AB is equal to the radical A, or square root of A, times the square root of B. And because of the symmetric property of equality, we can reverse that equation and know that the square root of A times the square root of B equals the square root of A times B. And these rules allow us to multiply radicals. So if, for example, we get an example like radical 25 times radical 4, all we do is multiply those radicands, radical 25 times 4, which gives us radical 100, and then we simplify, and the square root of 100 is equal to 10. Let's take a look at a few more examples. So here I've got the square root of 5 times the square root of 10. I'm just going to rewrite that as a square root of 5 times 10, which is, of course, the square root of 50. And I know that 50 is the product of 25, which is a perfect square, and 2. So I'm going to break that down under my radical sign, and then take the square root of 25, which is 5, bring it out from under the radical sign, and 2 remains under the radical sign, so the product would be 5 radical 2. Let's take a look at another example. We've got 6a cubed times, the square root of 6a cubed times the square root of 18a. So I'm going to multiply those radicands. So that'll be 6 times 18 times a cubed times a, multiplying coefficients and then multiplying variables. And I will get the product of that will be 108 times a to the 4th. Now, I'm going to simplify that, and I know because I've gone through all my square root factors until I find the largest perfect square that 108 is evenly divisible by, that 108 is the product of 36 and 3, and then a to the 4th is a squared times a squared. So I'm going to take the square root of all my perfect squares. Square root of 36 is 6. Square root of a squared is a. Square root of another a squared is another a, so this is 6a squared. And what's left under my radical sign is 3. And so here is the product of the square root of 6a cubed and the square root of 18a. Now what happens when we get a cube root? Well, we're not going to be scared. We're just going to, we're going to multiply the radicands, put everything under the cube root sign, and then simplify. So I've got 4 times 4 is 16. A times a squared is a cubed. And b squared times b squared is b to the 4th. So I'm going to simplify this radicand looking for perfect cube factors. And I know that 16 is the product of 8 and 2. A cubed is a perfect cube, and b fourth is b cubed times b. So now I'm going to take the cube root of all these perfect cubes and bring them outside the radical sign. So the cube root of 8 is 2, cube root of a is a, cube root of a cubed is a, cube root of b cubed is b, and then what's left under my radical sign, and don't forget your index, is 2 and b. So I've got the product of this multiplication is 2ab times the cube root of 2b. So let's take a look at a couple of examples that are just slightly more complicated. Here in my first example I've got radical 3 times a quantity inside parentheses, and the distributive property does apply here. So I'm going to multiply radical 3 times 2 and radical 3 times radical 3. So that will give me, the result of that will be 2 radical 3 plus radical 3 times radical 3. And then when I simplify that, I'm going to get 2 radical 3 plus the radical 3 times radical 3 will just give me 3. And so here's the product of this multiplication. Now what happens when I have two binomial factors? What do you think happens? Well, that's right. You're going to multiply them just like you would multiply any other binomials, whether you use distribution, whether you like to use FOIL, or if you must use the box. Whatever method you use to multiply binomials will apply here. So here I go. I like to distribute. So that will give me 2 times 1 plus radical 5 plus 5 times 1 plus radical 5. And now I'm going to do all that distribution. I'm going to combine all my like terms and see what my product looks like. So here we go. We've got 2 times 1 plus 2 radical 5. Then I've got 5 times 1 and 5 radical 5. And let's take a look at my like terms. So I've got 2 and 5. Here are my integers. So to finish off, let's just take a quick look at dividing monomials with radicals. In the next video, we're going to look at dividing more complicated radicals. But right now, we're just going to look at some monomial expressions. So if I have the square root of 27a divided by the square root of 3a cubed, I can, just for illustration, put this all under one radical sign. And I can simplify it under the radical sign, if I like, and then simplify. So 27 divided by 3 is 9. A over a cubed will leave me with a squared in the denominator. So now I've got a perfect square, 9 over a squared. I know the square root of 9 is 3, and the square root of a squared is a. So when we're dividing monomials with radicals, we're just going to simplify the numerator and denominator, remove all common terms, and then we can do our division. Let's take a look at one more example. Actually, we're going to look at two more examples. Let's take a look at our first one. We've got the square root of 35a cubed over the square root of 10a. So I'm going to put everything under one radical sign for the time being, and then I will simplify it. So I've got 35a cubed, the square root of 35a cubed over 10a. So let's see if we can simplify this a little. 35 is 7 times 5 times a cubed. 10a is 2 times 5 times a. Well, 5 over 5 is 1, so we don't have to worry about that. And a cubed divided by a is just a squared. Now I know that a squared is a perfect square, so I'm going to bring that outside my radical sign, which is a, and then I've got 7 over 2 left underneath the radical. Now we don't like to leave fractions in our under our radical signs, but for the time being we're going to stop here until we learn how to rationalize denominators. Let's take a look at this last example. Radical 72 plus radical 54 over radical 18. So the first thing I'm going to do is I'm going to split this into two different division problems. I've got radical 72 over radical 18, and I've got radical 54 over radical 18. And now what I'm going to do is I'm going to put each one of these underneath its own radical sign and simplify it. So I've got radical 72 over 18 plus radical 54 over 18. Well, I know that 18 goes into 72 4 times, and 18 goes into 54 3 times, excuse me. I also know that the square root of 4 is 2. Can't do anything to simplify the square root of 3, so I've got 2 plus radical 3. So again, I split this into two separate problems, simplified each one, and then got my quotient.